Alrighty, so today what we're going to talk about is solving inequalities algebraically. So these are 8.9 notes. You can call them Solving Inequalities Day 2 or Solving Inequalities Algebraically. Either one of those is fine. But before we start solving these problems, I want us to remember the steps that we used. These are going to be the same steps that we've used when we've solved inequalities in other functions. Okay, the same steps. So you don't have this written down, so just kind of write down these steps somewhere before you get started on these problems. So if you'll remember, our first step was always to rewrite the inequality as an equation. Okay, and then we solved that equation. Then, if you'll remember, we looked at the domain and we found any domain restrictions. Do you remember that?
Uh-huh. Oh, yes.
Because remember that our solution to an inequality has to be x values that were originally in our domain. These two steps, solving the equation and finding your domain restrictions, those develop which values? What do we call them? Your critical values. These are your critical values. So then you take your critical values and you plot them on a number line. And then what do?
You test points.
Yeah, you're going to test points to find your solution. So these steps aren't new, okay? It's a different function that we're plugging in here, but these steps aren't new. And that's just what you want to keep reminding yourself. Does everyone have this down that would like it? Okay. All right, let's go ahead and look at number 1. 2 to the x is greater than 4 to the x minus 1. So my first step is to rewrite this as an equation. So 2 to the x equals 4 to the x minus 1. You want to solve it. We've got a variable in the exponent, so what do we always try to do? Get the same base. Are we able to get the same base here?
Yes.
Yeah. If we weren't, we'd have to use our calculator strategies that we talked about a couple days ago. But in this case, we are able to get the same base. So this is going to be 2 to the x equals 2 squared to the x minus 1. What do I need to do with this 2 and x minus 1? Distribute. So I'm going to have 2 to the x equals 2 to the 2x minus 2. Then what do I get to do? Good. So the exponents equal. So x equals 2x minus 2. Negative x equals negative 2. So x equals 2. So that's one critical value. Then we check our domains. Do we have any domain restrictions on these two functions? No. What kind of functions are these? These are exponential functions. Think of your exponential graph. Are there any domain restrictions? No. So our domain on both of these are all real numbers. So am I going to get any critical values from this? No. So I'm only concerned with the x equals 2. Is x equals 2 going to be included in my solution? No. Why not? Good. It just says greater than, not greater than or equal to. Okay. Pick a good value to test. What do you want to try? 0. Okay. So let's test x equals 0. 2 to the 0 is 1. Is that greater than 4 to the negative 1? What's 4 to the negative 1? 1/4. Is 1 greater than 1/4? Yes. All right, let's check a number over here. Let's try 3. 2 cubed is 8 bigger than 4 squared, which is 16? No. Okay, so I want you to think about exponential functions. Exponential functions are always either increasing for growth or decreasing for decay. Would you agree? So once a function switches from being greater than another one to less than, it's not going to go back. It's always increasing or always decreasing. So while you should test both sides, because with other types of functions it's not always going to be the case, you can take some comfort in knowing that in exponential functions and then also in log functions, because we saw the graphs yesterday, we know once they cross, that's it. In one part of the graph it's above, in one part of the graph it's below. Okay? So you just want to pay attention to the graphs so that you know you're only going to have shading on one side. Okay? So what's our solution here? Negative infinity to 2. Tell me what that means.
2 to the power of x is greater than 4 to the power of x minus 1 up to...
Okay, not quite, Katie. Yeah, I can plug in any value less than 2 for x and get a true statement. Those are the numbers that make that inequality true. All right, I'm going to give you about 2 minutes. Work with a partner on number 2. Let's get going. We're not going to take a lot of time on this. I would choose to use a base of 2 here. 2 raised to what power gives you 1/4? Negative 2. And 2 raised to what power gives you 8? 3. All right, keep going. But you're not allowed to apply operations. You can only rewrite. I mean, I guess if you want to use a base of 64, you could, but that's could you done it? Yeah. No, because 1/4 to a power is not.
You get 3/5. You get 3/5. You get 3/5. That's what I got. It's gonna eat my eyes. You got some chocolate.
All right, what did you choose to test?
0.
Okay, if you tested 0, did it work? Yeah. That side works. If you test 1, will it work? No. So my solution is negative infinity to 3/5 with a bracket. Good. So you're going to have negative 2x equals 3x minus 1. Or sorry, minus 3. So negative 5x equals negative 3. Divide both sides by negative 5. Okay, let's try some log inequalities now. So we've got log of x minus log of 2 is less than or equal to log of 75. So I'm going to start by rewriting this as an equation. My first step to solving this equation is going to be to condense the left side. So it's going to be log of x over 2 is equal to log of 75. What am I allowed to do then? What's them?
X over 2.
Good. What do we call those? Arguments. Set the arguments equal to each other. So x over 2 equals 75. So what does x equal? 150. Okay, let's talk about our domains. Are there any x's in our arguments? Yeah, we have one log that has an x in the argument. So we take that argument and we set that argument greater than 0. In this case, that argument is just x, so we know that our domain is x greater than 0. Okay? So we're going to plot this on a number line now. I'm going to have 0, and I'm going to have 150. At 0, are we going to have an open or a closed circle? Open. Do I need to test anything to the left of 0? No, because your domain is greater than 0. So I like to draw an arrow. You might like to cross off the part of the number line you can't use. Whatever you need to do, but don't let yourself do more work than you have to. There is no need to have to test anything over here. Okay? What about at 150? Open or closed? Closed. Because this is an equals to 150, and we want less than or equal to. All right. When you pick a value to test, you want to be strategic. Okay? You either want to pick something that will specifically help you knowing your base, or something that we have a rule for. So one rule we know we have is log base anything of 1 is what? 0. So taking 1 as your argument is always pretty helpful. So let's go ahead and test x equals 1. So if I test x equals 1, I'm going to have log of 1 minus log of 2 is less than or equal to log of 75. Okay, log of 1 is 0 minus, think about log of 2. Is that a positive number or a negative number? It's going to be a positive. Think about your graph of log base 10. You really need to kind of think about your graphs on these problems. Your graph of log base 10 looks like that, right? What is this point right here? 1, 0. So anything after 1 as your argument is going to be a positive number. It's a positive number less than 1, though, because we know that log of 10 is 1. Okay? So we have 0 minus some positive number has to be less than or equal to log of 75. What can you tell me of log of 75? It's a positive number between what two values? No. Between 1 and 2. Because log base 10 of 10 is 1, and log base 10 of 100 is 2. So it's somewhere between 1 and 2. So you're going to have to kind of use your reasoning skills about what you know about graphs, your log graphs in these problems. So we've got So, is this a true statement? Is 0 minus a positive number less than another positive number?
Yes.
Yeah, this is a negative is less than a positive. So that works. So you have to go. What might be, we're not going to, but what might be a good number to test over here?
200.
5.
Either 200 would maybe be a good one. I would say 1,000 would maybe be a good one because we know that 10 cubed is 1,000, right? You need to be strategic about your bases. So my solution here is 0 to 150. I'm sorry?
How do you know the point?
How do you know the point doesn't work?
What point doesn't
How
work?
do you know it's not on the right of the
Yeah.
150?
After 150.
Okay, because I remember I told you that because a log graph is always going to be increasing or always going to be decreasing, once you cross that intersection point, you're always going to be below or always going to be above. So it's always only going to be on one side, but you need to test both sides to check yourself. Okay? All right, let's look at number 4. Log of x plus log of x plus 9 is less than 1. So this is going to be log of x plus log of x plus 9 is equal to 1. Condense your left side. Log of x squared plus 9x equals 1. What might we do from here? Rewrite it as an exponential. So this is a base 10. 10 to the first is equal to x squared plus 9x. So we subtract our 10 to get this set equal to 0. How does this factor? Right, x minus 1 and x plus 10. Anytime we solve a log function, we have to check it back with our arguments. Do both of these values work in our arguments? No, which one does not? Yeah, the negative 10. If I plug in negative 10, I'm going to have log of negative 10, which does not work. All right? Let's check our domains now. Notice that we have x's in both our arguments, so we need to look at 2 domains. What's the domain of your first log? X is greater than 0. What's the domain of your second log? X is greater than negative 9. Now, the good news is that you don't have to concern yourself with both of these. You need to pick the most restrictive domain. Okay? And what I mean by that is you need to pick the domain that has both of them in it. Okay? So if you think about this domain of x greater than negative 9, would you agree that negative 1 is a value that's part of that domain? Yeah. But is negative 1 a value that's in that domain? No. So you can't use, you have to use the more restrictive domain. So x greater than 0 is the more restrictive domain. It includes fewer values. Okay? It's the one that includes both. All right, so we're going to plot our number line. Got 0 and I've got 1. 0 is going to be an open circle, and I'm only concerned with values in which direction? To the right. 1 is going to be what kind of circle? Open. Okay. Now we need to pick a strategic value. What's our base? 10. So what about 10? Okay. Let's try 10. So I have log of 10 plus log of 19 is less than 1. What is log of 10? 1. What type of number is log of 19? A positive number. And it's actually a positive number bigger than what? It's bigger than 1, right? Because we know log of 10 is 1. And it keeps increasing. So, I mean, all you really need to know is that it's positive. Okay? So, is 1 plus a positive number going to be less than 1? No. So 10 doesn't work. What would be a good number to test in between these two values? Yeah, 1/10. Okay? If you test that, you're going to get it to work. So my solution is what? 0 to what? Questions on that? All right, let's try number 5. 2 times log base 49 of 2x plus 1 minus 1 is less than or equal to 0. All right, start by rewriting this as an equation. Okay, let's start solving this equation. What do you think might be the first step? Add the 1. This is going to be 2 log base 49 of 2x plus 1 equals 1. Sorry. From this step, you've got 2 options with that 2. What are the 2 things you could do? Yeah, you could make it an exponent, or you could divide by it. You're going to get to the exact same place. What would you rather do? Okay, let's divide. So we're going to have log base 49 of 2x plus 1 is equal to 1/2. What might we do from here? Yeah, rewrite this as an exponential. So this is 49 to the 1/2 is equal to 2x plus 1. Well, that works out nicely. What is 49 to the 1/2 power? 7. So 7 is 2x plus 1. So what's x? 3. Questions on that process? Yeah.
So why wouldn't it be -7? Why wouldn't you have to solve for -7? -7 squared
Because you are not writing in the square root. The reason you don't have to do the plus or minus is you are not applying the square root in order to solve. The square root is built into the problem. You didn't make a choice to use it. It was already there. Okay? Okay, let's look at our domain. How do I find the domain? Good. Take your argument, 2x plus 1, and set it greater than 0. So 2x is greater than -1. So x is greater than -1/2. Okay. Let's plot this on our number line. -1/2 is going to have what kind of circle? Open. And which side are we concerned with?
Right.
To the right. What about 3? Closed. All right, pick yourself a strategic value. I think 0 would be a good one here. What's 0 going to make your argument? 1, which we can deal with easily, right? So let's test x equals 0. So I'm going to have 2 log base 49 of 2 times 0 is 0, plus 1 is 1, minus 1, and I want to know if that is less than or equal to 0. All right, well, what is log base 49 of 1? 0. So this is 2 times 0 minus 1 is less than or equal to 0. Is that true? Yeah. So this works.
Wait, how did you know log 49 was 0 again?
I'm sorry?
How did you know that was 0?
Any argument, any base, no, anytime the argument is 1, no matter the base, it simplifies to 0. It's one of our properties. Because anything raised 49 to the 0 power is 1. Anything raised to the 0 power is 1. Okay? So what's our solution?
-1/2 times 3 close bracket.
Questions on that? Okay, I'm going to give you about 2 or 3 minutes on number 6. I want you to get to the number line. Find your critical values and get to the number line. We'll test the points together. You are going to have to do a little multiplication on the side of your paper. You are just fine. I promise. So get started on number 3. Sorry, number 6.
It has a log base 3.
You should know 3 to the 4th, so all you need to do is multiply it by 3.
You start with 0, not 5. It's greater than 0, not 5. So it's times 5. It's greater. You want your x to be greater.
All right. Hopefully everyone was able to get here. Are there any questions on these steps? All right. What kind of circle is going to be at 5/4? Open. And which side are we going to want to test points on? The right. What kind of circle is going to be at 62? Open. All right. Be strategic. What might be a good number? 6/4. I could see working. 2 would also work really well. Okay? Either one of those you want to do. Let's try 2. So let's see why we could have come up with x equals 2. Remember that your goal is to get a power of your base in your argument. So if you plug in 2, Notice that you're going to have 4 times 2 is 8 minus 5, 3. You have log base 3 of 3. So it's strategically picked to make your argument something you could work well with. So you have to be strategic about the numbers you pick. What is log base 3 of 3? So is 1 greater than 5? No. So it's got to be on this other side.
Is it only going to be one section?
Yes.
Yes, but you want to check both so that you're careful. There's a lot of ways to make mistakes. What, Shelby? Nope, because it's only over here. Okay, let me give you some hints for your homework, please. Let me give you some hints for your homework, please, if you'll stop talking. Okay, things can get a little more challenging than this, so you're going to have to power through a little bit, but I want to give you some hints to help you. You do not have to get exact values when you test points, okay? You just need to be strategic. So I want you to think, you're going to probably want to write this down. I want you to think about log base 7 of x. Anytime your base of your log is bigger than 1, remember that that has a shape that goes through the point 1, 0 and looks like that. Does everyone agree with that? Okay, that graph is increasing or decreasing? Increasing. That graph is always increasing. So what that lets us know is that if I have log base 4 of 12, or sorry, log base 7 of 12, and log base 7 of 4, which one of those is bigger if the graph is always increasing? Log base 7 of 12, because the x value of 12 is over here. The x value of 4 is over here, so this y value is above that one. So this one is bigger. Everyone okay with that? I have no idea what those actual values are. I just know which is bigger, and that's what you're going to be comparing. But what if you're dealing with log base 1/7 of x? What does that graph look like? It's decreasing, right? It looks like that. So in this case, log base 1/7 of 12 compared to log base 1/7 of 4, the 4 one is bigger because that becomes first, so that y value is higher up. Does that make sense? You're going to have to just reason through a little bit. Another thing I want you to think about, sometimes you might have more than one log on one side, but we know how to condense those. When you're testing points, you're going to want to condense so that you can compare one argument to the other. Okay? So you're thinking about increasing graphs versus decreasing graphs. Everyone okay with that? So the numbers might be a little more challenging, but I really need you to power through and give it all you got.